I'm so grateful that you could come and join us here for this event. I was also very glad to have a beautiful conversation with you last night at the Internet Archive. That was so much fun.
Indeed.
You had some thoughts that you wanted to talk about. Maybe you just start.
No, I think you were, I thought you were going to ask me, why did you get involved with this whole enterprise?
So I thought it was almost obvious, but for me, this thing is, why should we research machine consciousness is a very weird question. I remember that when I was in Boston, I gave a talk about this at an event, and they asked me to prepare at the Toastmasters Club and run through my talk. And there were basically two messages that I got as feedback from my audience. The first one was, you need to cut 90% of the ideas and speak much more slowly. The other one was, why would you want to build such a thing? Why is that important? And to me, this seems to be so obvious that we want to understand how a thing can become self-aware and understand this computational paradigm. But Stephen, so how did you get involved with us? And why?
Yeah, you convinced me that it was interesting. But more seriously, I think it's kind of interesting to see this arc of development, that consciousness was something in the domain of philosophy, and it's been talked about in philosophy for as long as we know that philosophy has been written down. And it is an interesting trend that what starts as philosophy has ended up with science. Natural philosophy turned into kind of ideas about science. And I think one of the things that I've been excited about in recent years is sort of the fact that we've managed to make scientific progress on lots of kinds of things we didn't think we'd ever make scientific progress on. I mean, for myself, the most exciting thing in recent times has been realizing that it looks like we can basically derive the fundamental laws of physics. Not just know them as things that the universe happens to have, but derive them as necessary features of the way that we are as observers of the universe. And so I think it's sort of, with that trend, there's the question of, can we finally take what has been sort of a philosophical pursuit and turn it into something which is more like science? And that raises the question of, what kind of a field is it that you are trying to build? Because every field has its sort of methodology. If you're mathematics, you prove theorems. If you're doing medicine, you do clinical trials and so on. The question is, what is the texture? What will CIMC actually, you've got to, not only do you have to actually do the science, but you have to develop the framework for thinking about how you present the science and so on. I think, the thing that got me into thinking a bit about consciousness recently was as an applier of the idea of consciousness, because I was mentioning this kind of notion that it's possible to kind of derive the laws of physics from a knowledge of what we are like, requires us to know something about what we are like. And so the main thing that I kind of concluded is, well, there's sort of a longer story. We talked about it a bunch yesterday, this concept of what I call the Roolead, this entangled limit of all possible computations, that is this sort of inevitable object, and we have to be a part of that Roolead object. And the question is, that Roolead object has sort of everything in it, but the issue is, what do things like us perceive in that Roolead that has everything in it? And the thing is that we have to know what's special about us. And the two things that seem to be important are that we are kind of computationally bounded, and that we believe we are persistent in time, and we have this sort of single thread of experience. And it seems that particularly that second one, is closely related to things about kind of the way that we see ourselves as being conscious and so on. And so I guess for me, I'm mainly, my initial interest is kind of, to apply whatever it is that is special about us as a way to describe how we are perceiving the things that exist in our universe. And it to me is very remarkable that with just those two kind of assumptions about what we are like, we're able to know that the physics that we observe has to be the physics that we know is the way things work. So that's, and I suppose that the thing that, this is a certain moment in history where both from a scientific point of view, we've reached the point where, particularly using the computational paradigm that I've been involved with for the last 40 years or so, that, within the computational paradigm, we're kind of opening up lots of different things that can be made scientific, and also the technology of AI and so on, including many things that most of us, I think none of us really expected would happen the way that they have happened with LLMs and so on. This is sort of a certain moment in history where there's sort of a chance to do what I think is your mission, to sort of scienceify the kind of the notion of consciousness and understand kind of a computational. I would say, computational consciousness is sort of is there a computational theory of consciousness, and what would it look like? It's not even obvious there would be a theory, because it's not obvious that, to say that there is a theory is to say that the thing that is going on in the world is something that you can kind of compress into a thing that will fit in your finite mind and that you can have some narrative about. And it's not self-evident to me that even in neuroscience or something, that there's a sort of a theory of that kind. I mean, for example, in machine learning, one of the questions has been, why does machine learning work at all? Which I think is closely related to the question of why does biological evolution work at all? I think I've figured out some things in recent times about the answers to those two questions, but I think that those are perhaps precursors to answering questions about your interest in kind of consciousness. So
I think a thing that we have in common is our fascination with the computer. For me, this began when I was about 9 years old. And I managed, after teaching myself how to code, to convince my family to get me a Commodore 64. And I was sitting in front of that thing, and I realized anything I fully understand, that I totally understand, I can put behind the screen and make it show up on the screen. And so then I thought, of course, what is the thing that I want to put in there? Well, an entire world, universe. And it should be full of minds that we can actually talk to. This was the obvious thing to go for, and I think this was when this perspective was born. And I later realized that this perspective, that we can understand things by building them, that we can model the world as discernible differences, as information, and the way in which these patterns change the evolution of these state transitions. That this is a very general paradigm, a metaphysical paradigm that we can put in this whole, where Western science currently has a lack of connecting metaphysics. This computer science perspective is not just a field that is about applications in computing and how to build computers and how to build applications. It is a philosophical tradition that is following from Leibniz and Tarski and many others, and is developing into a unified perspective on which we can build philosophy that is combining phenomena like foundational physics. It from bit is a paradigm in which you have been extremely important and instrumental in its development, and the way in which people got inspired to take it seriously, to adopt it, to use it as a frame, to understand that the universe is something that becomes comprehensible if we understand it at this evolution of transitions.
Well, I think this notion of computation as a kind of framework for formalizing things is one that is a critical thing of this century. It is the main sort of intellectual development, I think, of this century. Is that if you look at kind of the progress of systematic science, it's all about how do you take things which we kind of can just think about in the world, and how do we formalize these things so that we have kind of solid bricks on which we can build up kind of a tower of ideas. And that happened with logic. It happened with mathematics. It more generally happens with computation. I mean, the fact that we call it computation is an accident of history. I think the main point is that we are defining certain precise rules and then seeing what the consequences of applying those rules are. And that's something that's a methodology that I think is applicable to very broadly. I mean, the sort of computational X for all X is sort of an emerging practical thing that I happen to have spent the last 40 years kind of building an actual notation and language to enable computational X. But it's as a way of thinking about the world. It's our way of sort of formalizing thinking about the world. I mean, I see sort of computational thinking and philosophy as two rather closely related things. As far as I'm concerned, there's this sort of notion of foundational thinking that is what should be at the core of something like philosophy. But the question is, what is the hard methodology that lets you make progress in this area of foundational thinking? I think the answer to that is kind of computation. Computation is kind of the formalism for foundational thinking about things that has previously been, the best we've had to say about it is that it's a matter of philosophy, so to speak. And I think the question now for something like consciousness, which has been really mostly in the domain of philosophy, is I think it has some tentacles in neuroscience and so on, but I think in many ways it's kind of a philosophical pursuit. Now the question is, can one use computation as kind of a way to structure and build that systematically?
Yes, it's a way to look at reality as evolving patterns within patterns. And so there's the question, what is the kind of pattern that we're looking at? So for instance, we observe patterns that seem to be entirely mechanical, like particles that don't need to be intentional. We see some patterns which have a certain degree of intelligence, which can look ahead into the future and can only be explained by the ability to looking ahead by modeling the future. And we call these patterns agents. Right? An agent is a controller for future states, and so it is something that we can comprehend in this computational sense. And when we look at consciousness, what is the best way to characterize it? We might have a pattern that is observing itself in the act of observation, establishes itself as an observer. How would you characterize such an observer pattern?
Well, I think the thing to understand is the sort of computation in the wild, which is, so when we program computers, we typically have some particular goal in mind. We're trying to get the computer to do a particular kind of thing. But you can also, as I've done for many years, kind of look at programs in the wild. You just consider the simplest possible program, see what they do. The big surprise for me from the early 1980s was even when the program is very simple, the things it does can be incredibly complicated. So complicated that you can't predict what it will do, except in effect by running it and seeing what happens. So that's kind of the thing that one of the things I've kind of realized is that you pluck programs out of the computational universe at random. A large fraction of them will show this phenomenon I call computational irreducibility, where you basically can't jump ahead and see what the program will do more efficiently than just running it step by step. So now the question is, we've always felt that human intelligence and consciousness and so on are the tippy top of whatever might be going on in sort of the computationally definable world. I don't think that's the case. It's a bit disappointing, but I don't think that's the case. In other words, I think that the computations that go on that lead us to our sort of conscious experience and so on are actually a very small subset. They're very particular kinds of computations. I suspect having a lot to do with this phenomenon of taking lots of input from our senses and turning it into a small stream of actions that we perform, this kind of compression of taking lots of input, turning it into a small stream of actions. I suspect that's which is a very specialized kind of computation. I mean, it's kind of disappointing. We think, as we get smarter, we build better AIs and so on, we're going to be able to do more computation. It's going to be, but in the end, when we look at the natural world, it's full of computation, but it's computation that isn't of the same kind as the computation that we prize as being sort of conscious experience and so on.
I'm not sure why this is disappointing. I think it's surprising that we find ourselves waking up in this universe, that we can experience it, that we are here at all. But to think that this is because of me and I'm the most important thing in consciousness, that would be disappointing.
Stephen and Joscha, we promised a Q&A to our audience, and I don't want to miss on it. So
thank you.
I'm going to stop you for a second.
This is a repeat of what happened yesterday.
Exactly,
Yeah,
but no,
okay,
it's not. This time we will have the Q&A, but actually maybe not. I apologize for being so selfish, but I have the mic in my hands, and I could not resist. We asked this question to all our scientific advisors, Carl, Michael, and Christoph. Like, what is the kind of experiment you would design, like, to test for machine consciousness or verify some hypothesis there?
I'm not sure. I think the first question is, what should the methodology of experimental philosophy be? Because nobody's done experimental philosophy. It's not been a possible thing to do. Okay. So, I think that's the first issue. And I don't really know the answer to that. I mean, I think that you can do sort of psychology-style experiments. I think those are probably not the most interesting thing. I think you can, there are questions like, one feature of, a machine is that you can readily take it apart. And so, there are obvious questions about, what's going on inside the LLM when it does this or that. My guess is that that is not going to lead to interesting answers, because my guess is that what's happening, in typical machine learning is that you're kind of taking these lumps of irreducible computation and fitting them together in ways that happen to achieve the objectives you want. And those lumps of irreducible computation, there's not really a theory of what's going on inside there. It's just, it does what it does, and you happen to be able to recruit it and find it useful. So, but it is possible that there are sort of general principles of, there are features of what goes on inside that may have correlates with things that you think of as consciousness, and that's obviously worth looking for. I mean, I don't expect, unlike, I'm not expecting a pituitary gland of LLMs, so to speak. I mean, I don't think there's I'll be very surprised if there's sort of a particular thing that you can identify, pull it out, and say this is the consciousness generator for this system. I mean, probably, whether that's and I also will be. I suspect that the systems we already have are as competent. That it's not like there'll be some moment where one suddenly says, and we just added the consciousness bit, and now the thing behaves in a very different way. That's my guess, at least. But I think that one of the principal questions, which is I've not thought properly about, is this question of what is the nature of a good piece of experimental philosophy. So to talk about computation for a second, doing computer experiments. I've spent tons of time doing computer experiments, and it's not trivial to do a good computer experiment. People say, oh, I'm going to do an experiment on biological evolution, let's say. And they make this thing that sort of imitates the rainforest. And it has 312 parameters. And they observe that something or another happens. You can conclude nothing from this. And the trick, the thing is, can you make a really simple experiment where when you see something, it is surprising and you can kind of learn something from what you do. So there's a kind of methodology that you have to develop in doing, for example, computer experiments. There's a methodology. I mean, in philosophy, the methodology is often arguing with people. I mean, I had an early introduction to philosophy because my mother was a philosophy professor in Oxford. So one of the things I said when I was a kid is that one field I'll never get involved in, it's philosophy. My main argument was, if there's a field where people have been still arguing about the same questions for 2,000 years, this is a field that isn't going anywhere. But anyway, it's. That's a methodology of philosophy, is this continual argument type thing. In mathematics, it's who can prove the theorem and see all the results. What is the right methodology for experimental philosophy? I don't know. That has to be invented, and I think it's an important sort of initial step, is to think through what that's like. What constitutes a good contribution to experimental philosophy.
Yes, Aaron Sloman said in the 1980s, if philosophers of mind don't learn how to code, they will become irrelevant. And I think he was right. And they, for the most part, didn't learn how to code. We need to make progress in this field and find out what this methodology is. Do we have time for Q&A?
Let's make it.
Well, I just want to say one thing about that.
Yes.
The one...
No, I apologize. Please, Steve.
I just want to say one thing about the experimental side of things. This phenomenon that simple programs can do really complicated things. People really do not believe that until they've actually tried doing it. And I see people, including even myself, even after doing this for 40 years, I will constantly have the argument, oh, I'm looking at this kind of system, it will never be able to do this or that thing. And my usual statement to people working with me is, the computational animals are always smarter than we are. They always find some way to do this thing, even though we were sure it couldn't possibly work that way. But this is the fact that philosophers of mind have not had that experience of being sure that the thing they're making couldn't possibly do this, and then they try it and it does, is that that's an important intuitional moment, so to speak. I mean, when I first discovered this thing, it took me a couple of years to actually come to terms with what was going on. And at first, I was like convinced that there was some magic way to sort of break out of sort of the complexity that was being produced. Okay, questions?
What can you say today about the aggregate behavior in the evolution of branchial space. So in terms of like graph tangles or an analog of relativity.
Oh boy, that's a very different and complicated question. I mean, there's lots to say about what we've been able to do in the derivation of fundamental physics, from kind of underlying structure of thinking that what's in the universe is a network that represents space and everything in it, and this has led to kind of a whole way of deriving kind of features of physics that we know are there. One thing that's interesting from perhaps a consciousness point of view is in these models, quantum mechanics is inevitable. You have a model in which you have this network and you have these rules for rewriting this network, but there are many different places that these rules can get applied and many different orders of applying these rules. So the key thing about quantum mechanics is, in classical physics, definite things happen. In quantum mechanics, there are many paths that can be followed, and you only get to say things about probabilities of things happening. So in these models, it is inevitable that there are many threads of time that branch and merge and so on. So the question is, how do we perceive that? The universe is branching and merging. What is our perception of that? And why is it that we don't think that the universe is branching and merging? And I think the answer is that our brains, our minds, are also branching and merging. And so sort of the question of what you see in the universe has to do with how does a branching and merging mind perceive a branching and merging universe? And that becomes it's very similar, actually. If you say, how does an observer of the scale that we are perceive molecules bouncing around? The answer is they don't perceive the individual molecules. We only can perceive the aggregate of all those molecules that makes a fluid or whatever it makes. So similarly, in quantum mechanics, the thing we get to perceive is this aggregate across many different sort of threads of history. The other thing you might ask is, well, why do we believe, if there's this whole branchial space of all these different possible paths of history, why do we believe in objective reality at all? Why is it the case? Why is it not the case that it's kind of like that there are all these different branches you could go on, and these are all different realities? Why is there any objective reality? And I think the thing I've realized in recent times is branchial space is very big, just like physical space. There are things that we agree about. The things that, for example, typical example would be, what's the configuration of stars in the night sky? Physics does not derive the configuration of stars in the night sky, but we all agree what the configuration of stars in the night sky is because we're all on the same planet. We're all kind of nearby in physical space. So that means that we all have the same sort of point of view about what's going on in the universe. I think that's what's happening in quantum mechanics as well. And I think sort of the randomness of quantum mechanics is associated with the fact that we are at some particular place in branchial space, but we're kind of all very nearby. And so we all kind of agree about what happens, even though there are many possibilities for what could happen. But what actually happens is determined by the coincidence of where we happen to be. Just like we're not going to make a scientific theory that shows that we have to be on this particular planet in this particular galaxy and so on. And it's the same kind of thing in branchial space. So that's a rough. I mean, this is a long, complicated story, but that's at least a few thoughts along those lines that perhaps relate a bit to the consciousness question.
I'll take one question if we can do an answer in less than 2 minutes.
Depends on the question.
I think I have one that's like naturally somewhat quick, which is just, what do you guys think, if I force you to make it quick, to give like a probability between 0 and 1 or like 0 and 100%, that in the next few years, 3 to 5 years, we're going to build systems that are capable of experiencing states that qualify them for moral consideration. So like maybe systems that we're pretty confident have negative valence or are capable of suffering in a morally relevant sense. That's the 5-second question, and whatever you do say to that, if we do have more time, is like what kind of evidence would be required for you to change whatever probability you're about to say?
I would say that the chance that there are artificial intelligence systems that we care about the same way that we care about what happens with humans is very high. I mean, in other words, I think that it's worth remembering that when you have this sort of artificial intelligence that 1,000 people are friends with, and somebody says, should we switch off this AI? It's like, well, then 1,000 people are going to be unhappy. So I think it very quickly gets into the into a situation where you will feel about it the same kind of way that you feel about the thing that we know we have ethics about, which is people. And I think, ethics is one comment to make is that, the scientification of ethics is an interesting question. But one of the things that you start to realize is that typically in science, one of the things we're able to do is do sort of controlled experiments. We're able to separate, an effect from the rest of the world. I think in ethics that doesn't work. In other words, I think that if you say, should you make the trolley run into the 3 llamas or the giraffe or something, that isn't a question which you can that setup is even quite badly conceived, because it's not something we can separate off that question and answer it in the abstract. It really connects to everything else in the world, so to speak. So it's kind of denies the possibility of certain kinds of approaches to science that we've had. Anyway, my 2 cents on that.
I think I would very briefly like to say something about the second part, the moral consideration. It's we have this intuition when we interact with each other that the fact that somebody is conscious is sufficient for extending moral consideration to them. But this is a novel feature of our society. It has not always been like this, and it's also not in all ethics like this. For instance, in Bushido ethics, whether you suffer is absolutely not important. What is important that you do your duty. And if we are not equipped with our current ethics for dealing with a situation where we can just create new entities that are sentient and conscious and care, and where we can change them, where minds become completely mutable, where they become infinitely adaptable and can become whatever the situation requires. And so I think that our current ethics that we have that don't even allow us to determine at a global level what should be done, the moral direction that our society, that the social organism should be taking, is not equipped to deal with the situation, to deal with non-human agency. So we are completely stepping into new territory, into new ground. And this means we have to think, I think, couple level deeper to deal with the foundations of our morality.
So CIMC needs to solve that problem.
I'm not sure if we can do this, but I think that if we can create a space in which this question can at least be properly formulated, this is already a contribution.
Thank you so much. Thank you for this discussion.